Hello. For those who don't know me, my name is Alain Durand. I work in the office of the CTO at Comcast. I'm going to talk today about sharing potentially a single IPv4 address among many customers in our broadband deployment. So a bit of a disclaimer, this is not something that we claim we are actually doing or will be doing. It's more like a research effort at this moment. So we have all heard about it. The free pool of IPv4 addresses is running out, and this is going to hit us really bad. So we have been questioned about what will we do when there will be no more addresses to allocate to new customers. So some ideas about, okay, let's allocate v6 only to the customers and be done, and maybe translate v6 to v4. The problem is that people today in their home network have tons of legacy devices like Windows 95, 98, even Windows XP, who cannot survive in an IPv6 only environment. Even Windows XP cannot send DNS requests over IPv6 transport. So that's a bit of a problem. We cannot ignore all those devices. And on the other side of the internet, the web servers are all IPv4 today. And it's going to take quite a long time before every single web server on the planet is upgraded to v6. So on one side you have legacy v4 PCs, on the other side you have tons of v4 web servers, and those two still need to communicate, even though we may not have any v4 addresses to hand out to our customers. So we are in the middle, and maybe we have some bits of a solution. So it's kind of a short-term avenue before the world moves to v6. Trying to enable those legacy devices to still connect to the legacy internet, in a sense, but do not allocate one IPv4 address to every single broadband customer. Try to somehow aggregate that and allocate maybe one address per 100 customer or 1,000 customer, something like that. And still introduce v6 in the same time in the house so that new application can still use IPv6 and foster this v6 deployment. This is not about stalling v6 and just do v4. It's about, yes, getting v6 ready to be useful for new application, but still caring about the legacy. So, how to implement this? Well, we could start provisioning some new customers only with IPv6. So they do not consume any IPv4 address. And this could be said as, this is a different tier of service. So if you really, really want your own IPv4 address and do not share it with your neighbor, maybe you will pay a little bit extra. Or the other way around, if you are willing to share your address with your neighbor, maybe you will have a discount, something like that. So I'm assuming that there are pieces that we can upgrade, and essentially the home gateway is a piece where we would like to focus. And assuming that we are going to allocate prefixes to customer, not just a 64, but something larger, but we can do things with it. And essentially the idea is that we are going to do a double NAT. So in the home there will be private v4. There is only a v6 global address, so we'll translate this private v4 into this global v6, send it somewhere in the core of our service provider network, and translate it back into global v4, and aggregate many customers on this translation point. And still offer v6 as a native service. So I have a diagram. Things like a picture is better to explain what this is all about. So on the left-hand side, orange, this is v4. On the right-hand side, blue, this is v6. So you have this new home gateway, which is going to have some of the intelligence. It will have a v6 only connection to the service provider network. It's only provisioned with a v6 address. In that case, this is the 2001 colon something. It has a prefix, /56, so it can distribute it different subnets. So all the v6 stuff is going native, and the v4 stuff, it's allocated in private address space, so 192.168, just as usual, so nothing really changed from a user perspective. And this will be translated. So instead of translating this into a global v4, we'll translate this into a global v6. So from there, nothing really changed very much. The translation is very simple. One is a one-to-one mapping between that private v4 and that v6 address. And we send this packet to essentially a farm of translator that will be somewhere in the core of the service provider. And that will do the reverse translation from IPv6 to IPv4. So the trick to do that is, of course, to embed the source and the destination v4 address inside of a v6 packet. But this tricks that have been used many, many times, so this is really not something new. One of the challenges to do that is how do we scale this form of translator? Because we cannot have just one translator for 1 million customers or 10 million customers. It's never going to work. So horizontal scaling is good. Any kind of anycast is good. We can also help the customer to discover this using some kind of DHCPv6 parameter. So we can tell this customer, oh, your form of translator is there. And if we have 100 customers who are pointed to the same place, well, essentially we can have a 100-to-1 reduction of the number of IPv4 addresses that are being consumed. So here's an example. So in the home gateway, let's say that you want to send a packet from 192.168.1.2 and you want to send it to an address that's 198.108.150. I've taken, I think, the web server from NANOG here. Well, you translate this into a v6 packet. So the source of this packet is a prefix that has been allocated to you. There's a bunch of zeros, and then there's your source address, 192.168.1.2. And the destination address will be a specific prefix that has been advertised by your service provider, and you pad the v4 address of the destination you are trying to reach. The provider translator is going to advertise in this local routing system this prefix M, so that it will intercept all the traffic going to the v4 internet and allocate a port and maybe a bit of an IP address so that you can send the packet to the global IPv4 internet. So there is no magic. It's fairly simple NAT technology. It's simply going from v4 to v6 back to v4. And instead of allocating one address per customer, you allocate your addresses on this pool of translator, this form of translator, and you can have this reduction, maybe 100 to 1 or 1,000 to 1, depending on how aggressive you want to be. So some special consideration, while DNS, just like any other application, can be translated, or you can have a DNS proxy in the home gateway. There's some issues about MTU adaptation, but it's not really something that is very troublesome. I mean, we know how to deal with that. Of course, it will not work with every single application, but the opposite is you stop growing your business. So it's probably a lesser evil. It's not really worse than regular NAT today. It's just that we move a point where the NAT is done from the customer edge to inside of your network. Couple questions that have been asked to me many, many times. Why not using tunneling instead of NAT? Well, the answer is that if you do a v4 over v6 tunnel, you still need a v4 address. And that's really the problem I'm trying to solve. I don't have a v4 address anymore to allocate to every single customer. So tunneling is not going to help. And I cannot even put a net 10 address because in my network we ran out of net 10 2 years ago. So any solution that says, yeah, oh, yes, just use net 10 is not going to work. Why not use double IPv4 NAT? Well, exactly for the same problem. Net 10 is too small, so I cannot simply use net 10 here. Why not simply deploy v6 only in the home and be done and just put a NAT PT at the edge? Well, if I deploy v6 only in the home, all those legacy devices like Windows 95, 98, XP, they will be dead. And I care enough about my customers, so I don't want this to happen. And what about the new v6 only host trying to reach the v4 internet? Well, just take one problem at a time. Today those devices do not really exist, so there might be some solution based on proxies, but that will be the topic for another talk. So I think that's my last slide, so if you have questions, I will be happy to take them. If you are interested, I will be here all week. Already started to talk to some vendors on how to create some prototype for this.
We have about 1 minute for questions.
Hello, Daryl Lewis, Cisco. I have a question. If net 10 is not big enough, would 240/4 be big enough?
If 240/4 was not tainted, the answer will be yes.
Any further questions? No? Okay, thanks very much, Alan.